going to be looking at real zeros, which again are just real x-intercepts of polynomial functions. This will probably be the last section we get covered before your test. And with the outstanding news that we now have 2 more virtual days after fall break.
Thursday and Friday's going to be virtual?
Yes, that was decided yesterday at the board meeting. I don't know what our plan is for that, but we're going to still try to have our test Friday, which means you'll need to do, we'll have to do, I don't know. We'll find something, okay? We'll find something. I'd like to start the next section, but I've seen how well y'all do watching videos and learning.
I'm not good at it.
Which I've also, let me pause this. Well, it sounded good. Okay, so we're going to be finding x-intercepts of polynomial functions. You think, I know how to do that. You plug in 0 for y. Yes, well, everything we've had so far has either factored very nicely because it had a GCF, or it went into the quadratic formula, or we just told you what the x-intercepts are. Well, in the real world, it's not that easy. Okay, so right here we're going to be given we're going to be given polynomials and asked to find the x-intercepts of things that look like this: 6x cubed minus 19x squared plus 16x minus 4. But it doesn't have a GCF, and it's not a quadratic, and we've got to find the x-intercept somehow. Enter long division. Yeah. Woo!
Let's go.
Okay. You guys remember doing long division last year?
Yes, and I hated it.
Oh, we did.
You would have done it for a minute, and then you probably learned about synthetic division right after. Where you put the thing in the box. Yeah, you know, you use the box up here. You got like 3, and then you're like 1, 4, 7, 2, and you're like 1, 3, 7. Okay, this is an extension of long division. We will in a second. We will in a second. Okay. The graph, blah, 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 to the right, it appears x equals 2 is a 0 because f of 2 is 0. We know x equals 2 is a 0 of the polynomial function. So if x equals 2 is a 0, then x minus 2 is a factor. This means there exists a second degree polynomial cube such that f of x is equal to x minus 2 times q. One way to find q is to use long division of polynomials. It says here to divide the polynomial 6x cubed minus 19x squared plus 16x minus 4 by x minus 2 and use the result to factor the polynomial completely. Okay, so they're actually being kind of nice to us and telling us, hey, we think x minus 2 is a factor and you should divide by that. So, okay, let's do that. So we've got 6x cubed minus 19x squared plus 16x minus 4, and this is going to be divided by x minus 2. So this is our long division problem. Now, the reason I'm going to go over it, long division. Well, why are we doing long division if we can just do synthetic? Because synthetic only works in specific cases. Maybe everything you did in Algebra 2, synthetic would work for, but it's not going to be the case in precal. Okay, synthetic will probably work for 60%, 70% of your problems, but it doesn't work on all of them. So we're going to first do long division in a case where synthetic would work because they're easier. So just quick review. Let's remember how division works. So if I had to do 25 divided by 4. Okay, let me make this number longer. 257. I like that better. Okay. Can 4 go into 2? No. Can 4 go into 25? Yes. How many times? 6. 6 times 4 is 24. And then what do we do with these? Is there any subtraction sign here now? No, but we know the process of division includes subtracting those. I created this.
This is legit.
25 minus, yes, very good, is 1. Then we bring down the next term, the next thing to be divided. 4 goes into 17. 4 times 4 is 16. And we're going to bring that up again. The remainder is 1. But instead of writing it as a remainder of 1, we've got 2 options we could really do. We could add a decimal and bring down another 0, right? Do you remember that? Or we could write the remainder over what we divided by. 64 and 1/4 as a mixed number. This is exactly how long division works. Okay, so let's do it. We want the first term, x, to match the first term, 6x cubed. So how can I get from x to 6x cubed? I have to multiply by 6x squared. Questions? Now, we have to do the multiplication. 6x squared times x is 6x cubed. I made it match. Very good. Now I have to multiply again. 6x squared times negative 2 is negative 12x squared. We're basically distributing. This 6x squared has to be multiplied by everything over here. And then written underneath it. Now, what happened in our subtraction problem? I'm sorry. What happened in our division problem over here? We chose to subtract because that is part of the process of dividing. So what do I have to do now? I have to subtract, which means I'm changing the sign of everything on that line. Because if I'm subtracting all of it, I'm essentially changing the signs. So the 12x squared became positive. Now, 6x cubed minus 6x cubed cancels. And I'm left with negative 7x squared. And now I'm going to bring down my next term. Now the process starts over. I have an x leading, and I want to get rid of negative 7x squared. So I want to make them match. So x times what is negative 7x squared? Wrong. Correct. Negative 7x. Remember, I want to make them match because I'm going to choose to subtract them. I'm going to choose to change the sign. So I'm going to multiply by negative 7x. Negative 7x times x is negative 7x squared. Negative 7x times negative 2 is positive 14x. And now, division means I have to subtract these terms, which means I'm going to change the signs. So the 7x squared becomes positive. The 14x becomes negative. Now these cancel, and I'm left with 2x. I'm going to bring down the negative 4. Now the process continues. I have x. I want it to be 2x. So x times what is 2x? 2. 2 times x is 2x. I made it match. 2 times negative 2 is negative 4. And then I'm going to subtract, which means I'm going to change the signs. That's going to go to 0. This is going to go to 0. So I have nothing left over. So what does this mean? This means 6x cubed minus 19x squared plus 16x minus 4 is equal to x minus 2 times 6x squared minus 7x plus 2. Any questions about where I got this from? My original is now equal to the thing I divided by times what was left over as my result. Questions? Now it tells me to factor completely. So I need to see, can I factor this even more? Well, now this is a quadratic that I can factor using. You could find the zeros using the quadratic formula. I'm going to factor it because it told me to factor. So I would do a times c because my leading coefficient is not 1. So I can't look at it and identify it. So I'm going to go a times c is 12. What multiplies to be 12, added or subtracted, is negative 7. 1 times 12, will that work? No. 2 times 6, will that work? No. 3 times 4, will that work? Yes. Eureka. So I'm going to rewrite negative 7x as negative 4x minus 3x. You not like Eureka? You're not a fan of that? I can't remember who the mathematician was. God, that'd make a better story if I could tell you his name. Nope. He. I don't think that's him. He's not a mathematician. No. This guy would be in his apartment. Anytime he would make a mathematical discovery, he would go running around the neighborhood yelling Eureka.
Frederick Douglass.
No. No, but okay, so I need to, again, it's not Ben Franklin. So I'm going to go ahead and factor some more. Yes, Archimedes. Did you look it up? Did you Google it? Yeah. That's right, Archimedes. Yeah. So now then, when I factor here, my GCF is 3x. That leaves me with x minus 2. My GCF here is negative 1. Oh, I messed that up, didn't I? Hold on. Stop. Why didn't y'all tell me that doesn't make any sense? My GCF here is not 3, it is 2x, and that leaves me with 3x minus 2. GCF here is negative 1. That leaves me with 3x minus 2. So my parentheses match. So now I have x minus 2 times what's in front of the parentheses times the matching parentheses. So now I have now factored the polynomial completely. Okay, did we get the long division done?
Yes.
Okay, good. 3x squared. I mean, Whitfield just doesn't like me. I'm so sorry, Whitfield. I wish he liked me.
I'm going to not graduate, and it's going to be your fault. Like, I'm sorry. It's just going to be that way.
Hey, chill out. Jesus.
This is my only class that I'm struggling in. I literally have 99s and 11s, except for here.
Okay, well I got like a 71 here.
That's so
I'll take my
sad.
phone.
You
So
took
sad.
the easy.
You just gotta put your head down and grind. You can't let it get to that.
Took the easy road.
What? Can't let it get to you.
I tried to be an undergraduate of finance, but they wouldn't let me.
Thank goodness. Okay.
That's right.
If they just let people quit this class every time it got hard, it'd be a shame.
No, I'm not trying to quit.
Okay, now I've got to divide 8x cubed minus 1 by 2x minus 1. So I'm going to go a little quicker so Whitfield doesn't hate me. Okay, so I've got 8x cubed divided by 2x minus 1. Now here's the difference. I have 8x cubed minus 1. I've got all kinds of missing powers between them. There's no x squared term. There's no x to the first term. So in order to make the division work nicely, I'm going to add placeholders. So I'm going to have 0x squared, 0x, and then minus 1 at the end. That allows me to help keep place of where I'm at as I do the problem. Okay, so now let's do the division. 2x becomes 8x cubed by multiplying by 4x squared. 4x squared times 2x is 8x cubed. 4x squared times negative 1 is negative 4x squared. And so you see how that placeholder helps me line them up and combine my like terms. Now I'm going to subtract, which means I change the sign of everything. This is gone, and I'm left with 4x squared. Now I can bring down the positive 0x. Now same process again. I've got 2x. I want it to be 4x squared. So I'm going to multiply by 2x. 2x times 2x is 4x squared. 2x times negative 1 is negative 2x. And now I'm going to change the signs. This cancels, and I'm left with 2x. Bring down the minus 1. So now I've got 2x. I want it to be 2x, so I just need to multiply by 1. 1 times 2x is 2x. 1 times negative 1 is negative 1. And now I change the signs. Everything cancels, which means when I divide, I'm left with 4x squared plus 2x plus 1. So I've got x cubed minus 2x squared plus 0x minus 9 divided by x minus 3. So I'm multiplying by x squared. That should be x cubed minus 3x squared. I subtract. So that's going to leave me with x squared, 0x. So I multiply by x. That's going to give me x squared minus 3x. I'm going to change the signs. And now pay attention because I'm going fast. I may mess this up. That should be positive 3. And that's going to give me 3x minus 9. Okay. So it worked out, so I probably did it correctly. X squared plus x plus 3? Okay, so the first one here again is just a division problem. We're going to have to use long division. The difference here is the thing I'm dividing by this time has 3 terms, and we can see that the polynomial that I am dividing it's backwards, right? Our highest power is here. Okay, so I've got to do this division here. You see how I've rearranged it? I put my polynomial in order from the greatest term to the least term. And then it's being divided here. But it's still the same process that we have done before. I did not need any placeholders because I went from the 4th degree to the 3rd to the 2nd to the 1st to a constant. So I'm going to look at my leading term, which is x squared. I want it to cancel with 2x to the 4th. So x squared times what is 2x to the 4th? That would be 2x squared. And now we're going to multiply. 2x squared times x squared is 2x to the 4th. 2x squared times 2x is going to be 4x cubed. And then 2x squared times negative 3, that's going to give negative 6x squared. And then what do? We subtract this bottom row from the top row, so I'm changing the signs of all of my terms. And I'm going to combine them. Cancels, cancels, and I'm left with x squared. And I'm going to bring down my next 2 terms. So I have a positive 3x minus 2. And so now we do it again. What times x squared is x squared? That's going to be a positive 1. So 1 times x squared is x squared. 1 times 2x is 2x. 1 times negative 3 is negative 3. And now we subtract this bottom row, which means I'm changing all of the signs. Okay, so that's going to leave me with x plus 1. Now, I have an x squared as my leading term, and I want to rewrite it as an x. Well, that would decrease the power from a second degree to a first degree. When you get to that point, you can't go any farther. You need to stop. Okay, so we could say x plus 1 is our remainder. Okay, but the way that we would write it, we normally write our remainder as a fraction, kind of like a mixed number that we talked about when we did it on Friday. So my answer is, when I do this division, I get 2x squared plus 1 plus, and then we put our remainder in the numerator over the thing we were dividing by, which is x squared plus 2x minus 3. So when I perform that division, this would be my final result. But now here is when synthetic division can be used. The only time you can use synthetic division is when I am dividing by a binomial. So you see I have a first degree variable and then just the constant 3. If this is an x squared, can't do it. If there's any other power besides first, you can't do it. If you have a leading coefficient out here that's not a 1, you can do it, but it requires a little bit more work. So typically the only time we like to do synthetic division is when the polynomial that I am dividing by is a first degree binomial where the leading coefficient is 1. Okay, so this fits all of those. So synthetic is a little bit shorter than using long division. The way we do synthetic is you take here what you're dividing by, which is x plus 3, and think about solving it to find your x intercept. So if x plus 3 is a factor, then that means negative 3 is the intercept. So we put negative 3 in a box. And where did I get negative 3? From solving this, setting it equal to 0. Then all we do is we write down the coefficients, and we have to make sure we go in decreasing order by the powers. So my x to the 4th term is 1. X to the 3rd term is not there, so I have to put a 0 as a placeholder. X to the 2nd is negative 10. X to the 1st is negative 2. And then my constant is 4. Now we bring down the leading term. Then we multiply. 1 times negative 3 is negative 3. And then we combine. Negative 3. Then we multiply. 9. Then we combine. Multiply. Combine. multiply, combine. So what this means is, if I perform this division using long division, I would have a remainder of 1. This would be my constant coefficient. This would be the coefficient of the x to the first, x to the second, and x to the third. So I know if I do the division, I have 1x cubed minus 3x squared minus 1x plus 1 with a remainder of 1 over what I was dividing by. So if I perform the division, this would be the polynomial that was left. I know I did that kind of quickly, but I think that you have seen it before, so it's not unfamiliar to you. One thing I will tell you is, whenever I perform synthetic, I do a very poor job of saying what I'm doing out loud, because when I do it out loud, I always mess up. I don't know why. This is one thing that I can't talk and do at the same time. So if you have questions about this process, let me know and I'll try my best. This, you bring down the first term, then you multiply. 1 times negative 3 is negative 3. That's where that comes from. Then you combine these. So 0 minus 3 is negative 3. Then you multiply. Negative 3 times negative 3 is 9. Then you combine these. Negative 1. Then you multiply. Positive 3. Then you combine. Say again? That is just the coefficients of my original. So x to the fourth had a 1. There is no x to the third. So that's 0. X to the second is negative 10. X to the first is negative 2. Constant. It just has a 1. The fourth degree has a 1. You see how this is a fourth degree? You know what I'm talking about? So there is no third degree. So I have to put a 0 as a placeholder, like when we do long division. So this is the third degree. This is the second degree, the first degree, and the constant. Anything else? So hopefully you've got this one done by now. Again, I'm not very good at talking when I do this. So this time my remainder is 0. So I'm left with 5x squared minus 2x plus 3. When I do the division. We find that the remainder is 15. Then what they're saying is, if I plugged 4 into the function, I would get 15 out. Whatever the remainder is the same thing you would get if you plug that number in. That is the remainder theorem. So just to prove our point here, this tells me to use the remainder theorem to evaluate 3x cubed plus 8x squared plus 5x minus 7 when x is negative 2. So what we're going to do, we're going to put negative 2 up here in the box because this one is already solved. You know how the last one we were dividing by x plus 3? So we had to solve it to say x equals negative 3. Well here this is already solved, so negative 2 goes in the box. Okay, now I'm going to write down my coefficients, 3, 8, 5, negative 7. And I'm going to do the synthetic division. Okay, so when I did it, I found I should get a remainder of negative 9. So what the remainder theorem says is if I plugged in negative 2 here, For x, I would get negative 9. So let's just check that. So this will be 3 times negative 2 cubed plus 8 times negative 2 squared plus 5 times negative 2 minus 7. So that would be negative 8. This would be 4. This would be negative 10 minus 7. So this is negative 24 plus 32 minus 17. So when I combine that, that's 8 minus 17, which is negative 9. So again, the whole point of the remainder theorem is just a shortcut. It's another tool you can use to evaluate a polynomial by using synthetic instead of actually plugging in. Any questions? So like I said, everything I wrote with a marker was just me checking and proving that the remainder theorem works. That's not what you have to do. You just have to do this. Okay, so hopefully you are finished with most of these. Okay, so when I plugged in negative 1, I got out positive 1. And I'm going to plug in 4. Hit 396. Next I'm going to plug in a half. That's 4. That's 2. I get negative 6.5 or negative 13 over 2. And if I plug in negative 3, I get negative 17. The factored theorem says if you get a remainder of 0, then that means the thing you plugged in is an x-intercept. Because think about what's really happening. We're plugging in an x value. Say we plug in 3. What we get out is the y value, which would be 0. Well, if I get out a y value of 0, that means 3 is an x-intercept, because this is only x-axis. Every x-intercept has a y value of 0. So what we're saying is, if the remainder is 0, then whatever's in the box is the x-intercept. So that means if 3 is an x-intercept, then that means x minus 3 is a factor. Because again, what is our whole big deal? What are we doing here? We're taking those big, ugly polynomial functions. 4x to the third plus 3x squared minus 17x plus 1. So last section we learned about end behavior, we learned about turning points, we learned about x-intercepts, y-intercepts, and getting a general form of the graph. Okay, well what happens when you're finding x-intercepts but there is no GCF. Like, how can I find the x-intercepts of this? Well, we're going to start using synthetic division. We're going to start finding where I get a 0 as a factor, and that becomes an x-intercept. 3 is the x-intercept, which means x minus 3 is a factor. That means I can rewrite this as x minus 3 times something. And then once I factor that, I can find more x-intercepts. Okay, so that is what we're doing in our big picture goal. All that we've been doing so far has been learning these tools to help us find x-intercepts for our polynomial functions. So this is kind of the big deal of the section. So right here, they're still being kind of nice to us. They're saying, here is our polynomial function. F of x equals 2x to the fourth plus 7x cubed minus 4x squared minus 27x minus 18. They give me two factors. They say, show me that these two are factors, and then they tell me to find the remaining factors. Okay, so what does it mean if they're a factor? That means that they have a 0 remainder. That means if I plug in this x-intercept, I would get out a y value of 0. Okay, so let's first show that x minus 2 is a factor. So if x minus 2 is a factor, then that means x equals 2 is an x-intercept. I just find that by setting this equal to 0 and solving. So if x equals 2 is an x-intercept, then when I put 2 in my box and do synthetic division, if I get a 0 remainder, that means 2 was an x-intercept. So I'm going to write down the coefficients. 2, 7, negative 4, negative 27, and negative 18. And here we go. Bring down the 2. Okay, so I've done the synthetic division. I have found that I have a remainder of 0. So what does this mean? It means that the original can be rewritten as x minus 2 times, and then what's left here? This is 2x cubed plus 11x squared plus 18x plus 9. No remainder. So what have I done? I have factored this. Again, what are we doing? We're finding x-intercepts. So this is the first x-intercept. I know it's an x-intercept because I got a remainder of 0. Now, are there any more x-intercepts? Well, yeah, there could be up to 3 more because this is a third degree polynomial. So next thing I would look, is there a GCF here? No. Could I factor by grouping? No. So I still got 4 terms that I still don't know how to find the x-intercepts. So again, they're nice to me again and tell me x plus 3 is also a factor. So I'm going to take this. This is called a depressed polynomial. We call it a depressed polynomial because we have lowered the degree from a 4th degree to a 3rd degree. I've already found one factor. Now that I'm going to take this depressed polynomial and prove that this is also a factor of the depressed polynomial, which means it was also a factor of the original polynomial. So I'm taking x plus 3, setting that equal to 0. That means I'm finding there should be an x-intercept at negative 3. So negative 3 goes in my box. Then my coefficients are 2, 11, 18, and 9. Again, straight from the new depressed polynomial. I bring down a 2, and then I do synthetic division. And I got a 0 remainder again. Okay, so what is it that I have now? Well, I have my original x minus 2 that was factored out. I then factored out an x plus 3 because I just did synthetic division with a negative 3. Right, so I factored out x plus 3. And now what's left? I have 2x squared plus 5x plus 3. So I have now found 2 of the x-intercepts. And now right here there could be up to 2 more. So now I've got a quadratic. So you could use the quadratic formula. you could factor. I'm going to factor. I'm going to do A times C. So what multiplies to be 6, added or subtracted is 5. Okay, well, this one's the one you got to be careful on. Because 6 could be written as 1 times 6, which is 5, or 2 times 3, which can give me 5. So which one of those do I need? Yes. How do you know that?
You started with two. You did synthetic division calculator.
Yes, but that's not how we know right here that A times C is 2 and 3. That's true.
Both positive.
Yes. Yes. Because I know that they have to multiply to give me a positive 6, and then added needs to be a positive 5. So since they both are positive, I need it to be 2 and 3. Because 6 and 1 being 5 is going to give me 1 positive, 1 negative. So I know I'm going to rewrite this as 2x and 3x. So, okay. So that's going to give me, I'm just going to focus in here. I've got 2x squared plus 2x plus 3x plus 3. Now GCFs, 2x, that leaves me with x plus 1. GCF is positive 3, that leaves me with x plus 1. Now then this factors to be 2x plus 3 times x plus 1. And then I have my original 2 factors that are here out front. So I also have an x minus 2 and an x plus 3. So now I have factored the polynomial completely using synthetic division. And then I use the A times C method once I got it down to a quadratic. So again, if it asks me to find the X intercepts, which again is my big goal, the X intercepts are at 2, -3, -3 halves, and -1. Okay, where did I get those from? Just solve these, right? Set this equal to 0. So that would be 2x plus 3 equals 0. That means 2x equals -3, x equals -3 halves. And then the same thing here, x plus 1 equals 0. So x equals -1 is an x-intercept. So that means if at any point I would have put -1 in the box or -3 halves in the box, I would have also gotten 0 remainders. Because these are also x-intercepts. -3 halves and -1. Okay, so hopefully you've got a good start. I'm going to work it quietly. Can we go ahead and start working it?